Eating, sir. Wow. At the time of studying, eating. Ugh. Yeah. And I think tomorrow voice is coming. Voice is okay. Voice is coming. Yeah. Okay. No problem. Yeah. Yeah. Okay. Ah. And tomorrow, I think festival is also there now. Ugadi is there tomorrow. Ugadi is there. Yeah. Oh, nice. So enjoy the festival, but at the same time, focus more on studies. That is very, very important. Yeah. And you see today, completely matching. Background also blue. My shirt also blue. Yeah. Okay. Acha, it's not Ugadi. Huh? Ugadi or Ugadi? Ugadi or Ugadi? Ugadi. Okay. DHI. Okay. 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 Yeah. Okay. 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 No problem. No problem. Yeah. Okay. Yeah. So happy Ugadi, Ugadi to all of you. Happy Ugadi to all of you. All boys and girls, everyone, happy Ugadi. Yeah. Same to you, sir. Okay. Thank you. Thank you. Back to you. Okay. Okay. Thank you. Okay. No problem. Now, okay. 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 Yeah. Okay. So now let's start with the class. Let's start with the class. And I think in last class, did you realized? Yeah. Did you realize slowly we completed one chapter? In last class, we completed magnetism and matter. That chapter అయిపోయింది. Yeah. ఈ రోజు నేను న్యూ చాప్టర్ స్టార్ట్ చెప్తారా? Okay. Okay. Will I be starting new chapter? Okay. 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 Yeah. Okay. Exam was okay. No problem. Yeah. Okay. 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 Chestanu. Yeah. Okay. So we'll be starting today with the new chapter. We'll be starting with the chapter moving charges and magnetism. So you write the name of chapter moving charges and magnetism. I know my Telugu is good. Yeah. Slowly improving. Yeah. Moving charges and magnetism. Ah. Oh. Please, you only deal with hurt. Okay. Yeah. So, so we'll be starting with our new chapter. We'll be starting with our chapter moving charges and magnetism. Be focused, understand. It's a little long chapter. It's a little long chapter. And that's why from this chapter, you will get 3 questions in your NEET exam. You are going to get 3 questions. Now be focused here. Okay, no problem. Now be focused here. From this part, we are going to get 3 questions which will be asked in your NEET exam. So that's why it's very, very important chapter. So understand how we'll be talking about. And this chapter will come in 2 parts. Since we are starting this chapter, so I'm just giving you idea. This chapter will come in 2 parts. In one part, I will talk about moving charge. If external magnetic field is there now, in that magnetic field, if charge is moving, what will happen to that charge? So first part, I will talk about moving charge. Then I will talk about moving charge will produce electric current. Due to electric current, magnetic field will come. So we'll talk about first part where I will talk about what will happen to a moving charge in external field. Then I will talk about magnetic field produced by the electric current. So that's why this chapter will come in 2 parts. So first part will be talking about moving charge. If a charge moves in magnetic field, then what happens? So we are going to start with the chapter. You write one point. You write one point. You write, whenever any charge, very important, very conceptual chapter. Whenever any charge moves in, whenever any charge moves in external magnetic field, whenever any charge moves in external magnetic field, it may experience force. It may experience magnetic force. Whenever any charge moves in external magnetic field, it may experience magnetic force whose value is so we start this chapter with the value of magnetic force acting on a charged particle, whose value is now be 100% focused. So value of whenever you have any charged particle moving in magnetic field, then your charge may experience magnetic force. Value of that magnetic force is given as F magnetic will be coming as Q into V cross B. First you tell me what is V here and what is B here. F magnetic will be equal to Q into V cross B. What is V here? What is B here? Yeah, V is the velocity. That is your moving charge. This is what I told you. Whenever you have a charge moving in magnetic field. So V represents velocity of charge, B represents magnetic field. So whenever you have any charge in external magnetic field, moving in external magnetic field, your charge may experience magnetic force. Value of that magnetic force will come Q into V cross B. Now always be careful about one point which people ignore and make mistake. Always remember, never ignore nature of this charge. Always remember, if it is plus 2 coulomb now, you'll write value of charge as plus 2 coulomb. If they say electron, you'll write value of charge as negative. So always be careful, because here, yeah. So always remember, never ignore. People ignore this thing and get wrong answer in exam. Never ignore nature of charge. Nature of charge. If it is positive charge, if you want the direction of force, if you want force vector, you will always put the nature of charge. If your electron, if on proton force acts along x-axis, on electron force will act along negative x-axis. So always remember, never ignore nature of charge. I am saying, but still some people will do mistake there. So don't do that mistake. So come on, tell me, what is value of magnetic force acting on the charge particle? F magnetic will be equal to Q into V cross B, Q into V cross B, Q into V cross B. You tell me, will you ignore nature of charge? Will you ignore nature of charge? Will you ignore nature of charge? Never, sir. Never. We are not going to ignore nature of charge. Yeah. Okay, no problem. We'll talk about some questions from here. Okay, no problem. Before that, see few more points. Yeah. Acha, if you remember what I was telling you, if you remember, I told you in vectors that if A cross B is equal to C now, there I told you that means C will be perpendicular on A vector also and C will be perpendicular on B vector also. I told you about nature of cross product. Same thing is happening here. Be focused. If you see closely now, what you will find? Your magnetic force is coming with the help of cross product of V and V now. So always remember, your magnetic force is coming by cross product. That means magnetic force will be always perpendicular on velocity. And magnetic force will be also always perpendicular on magnetic field. And if force is perpendicular, that means acceleration will be also perpendicular on velocity. That means acceleration will be also perpendicular with magnetic field. That means acceleration dot velocity, this will also come 0, and acceleration dot B, this will also come 0. Remember this thing, all these things we have studied in torque also. If you remember, torque equal to R cross F, same thing we'll be doing here. So always remember, since your force comes due to cross product now, and you know result of cross product will be perpendicular on both the vector. That's why magnetic force is perpendicular and velocity is also perpendicular on magnetic field. If force is perpendicular, acceleration also perpendicular. And you know dot product of two perpendicular vectors will be always 0. First you write this. So always remember, magnetic force comes by cross product of velocity and magnetic field. That's why magnetic force is always perpendicular on velocity. That's why acceleration due to magnetic force is perpendicular on velocity. Now understand one point. Just here. Be 100% focused. One very important statement is asked. Be focused. If you see force, magnetic force is perpendicular on velocity now. Your magnetic force is perpendicular velocity now. That means if anyone asks you what is the power generated by magnetic force, you know power will be coming as F dot V. You know power will be coming as F dot V. We have studied about power. Power will be F dot V. And you tell me what will be F dot V for magnetic force. For magnetic force, what will be your F dot V? 0. Both are perpendicular now. So always remember, power generated by magnetic force is always 0. And if power is 0, that means work done by magnetic force, on charge particle, work done by magnetic force on moving charge particle will be always 0. This is one of the very important statement. What is the work done by magnetic force on a moving charge? Always 0. Magnetic force never change kinetic energy. because its power is 0. If power is 0, work done will be 0. If work done will be 0, delta K will be 0. So always remember, magnetic force cannot change kinetic energy of the particle. It can only change direction. So first thing you tell me, then we'll write the statement. What is the power generated by magnetic force? How much power magnetic force generates? 0, 0, 0, 0. Why magnetic force generates 0 power? Because perpendicular of force and velocity are perpendicular. Perpendicular means dot product will be 0. So magnetic force do not generate any power. Power generated by magnetic force is also always 0. If power is 0, what is work done? What is work done? Work done will be also 0. So always remember, work done by, you write this point, you write this statement, you write work done by magnetic force, work done by magnetic force on a moving charge, work done by magnetic force on a moving charge will be always 0. Work done by magnetic force on a moving charge will be always 0. Hence, it will never change kinetic energy. Hence, it will never change. Hence, it will never change kinetic energy. Hence, it will never change kinetic energy. I'm giving you time of 15 seconds. See all this situation, then we'll move further. Then I'll give you some questions from here. First thing, value of magnetic force, F magnetic will be coming as a Q into V cross B. F magnetic, Q into V cross B. We never have to ignore nature of charge. Don't ignore nature of charge. Sir, work done by magnetic force will be always 0. Power delivered by magnetic force will be always 0. If work done is 0, that means it will not change kinetic energy. Change in kinetic energy due to magnetic force is always 0. I'll give you one question. Come on, you write. 2-3 questions I will talk about, and this type of questions are very famous in your NEET exam. You write. One line question. An electron is projected in east direction. An electron is projected in east direction where magnetic field, an electron is projected in east direction where magnetic field is vertically downward. An electron is projected in east direction where magnetic field is vertically downward. Find the direction where magnetic field is vertically downward. Find the direction in which electron will deflect. Find the direction which electron will deflect. Yeah, very good. Someone has given the answer also. Oh, don't ignore nature of charge. I am saying again and again, deflect means in which direction force will act. They are asking you in which direction it will get deflected. Means you have to tell the direction of force. In which direction force will act on the electron. In that direction only it will deflect. Don't do mistake. Electron means minus charge. Everyone is saying wrong answer. What happened? North or south? Oh. South, Baba. See carefully. Don't do mistake. Oh. Easy question. Answer will come south. How people are saying north? Oh. Answer will come south, na? You'll simply say, sir, okay, they are asking us in which direction charge will deflect, means they are asking us direction of force. So direction of force, for that I know, sir, Q into V cross B. Now electron, don't ignore nature of charge. For electron, what will be this? This will be minus. You simply want direction, minus. V direction is given now. In which direction charge is projected? Come on. In which direction charge is projected? East. East means I cap. Don't you know? East means I cap. What is magnetic field? Vertically downward. Vertically downward. Vertically downward means minus k cap now. Vertically down. Minus k cap. Vertically downward. Yeah, vertically downward. Not on paper like this. Vertically downward on your copy is this inward. Yeah, that is minus k cap. Now you can write minus. Yeah, charge negative, so minus. Don't ignore nature of charge. Minus q into v cross b. What is v? V is I cap. Cross B. What is B? B is minus K cap. Hey Bhagwan. Yeah, from here we'll be simply saying we will get the answer very easily. This will be, this minus minus will make plus. So this will finally become I cross K. And what is I cross K? It is minus J. If you forget, if you remember one watch I told you, if you feel any problem, always use this watch in the direction of, yeah, clockwise positive. K cross I is J. Here you are getting I cross K. So I cross K will come minus J. That will be coming as south direction. Are Baba, did you understand? Bolo, 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 bolo. Come on, tell me. Chamki. Everyone understood? Huh? Yeah, okay. Yeah. So first thing, you tell me, many people said north. Why you said north? Where you did the mistake? Many people said me answer will be north. What mistake you did? Q, eh? Taken Jake, arey Baba. Vertical in your copy, vertical direction will be this. Yeah, this is north south, this is east west. Yeah, and Q electron, that's why negative. Okay. So this is how we can talk about and we can get. Okay, no problem. I will give you one more question. Come on, do one more question. Do one previous NEET question. You write. If the given charge remains undeviated, if the given charge remains undeviated in the magnetic field, if the given charge remains undeviated in the magnetic field, find alpha and beta. If the given charge remains undeviated in magnetic field, undeviated means force is zero. That means cross product is zero. Find value of alpha and beta. If the given charge remains undeviated in magnetic field, find the value of alpha and beta. Very good. Someone has given the answer. Yeah. Very good. Yeah, very good. Undeviated means cross product is zero na. Undeviated means force is zero. Force is zero means cross product is zero. Cross product zero means two vectors are parallel. At two vectors parallel, ratio of coefficient must be same. Hey Bhagwan, I'll be simply say, sir, charge remains undeviated. When your charge will not deviate, when force on the charge will be zero. If force on the charge is zero, that means Q into V cross B is zero now. That means from here I can say, sir, V cross B is zero now. You tell me when cross product of two vectors are zero. When cross product, yeah, okay, very good, very good. Everyone is giving the answer. When cross product is zero. When cross product is zero. Yeah, parallel vectors. Yeah, a cross product of the vectors will be zero for parallel vectors. That means if from here I can say V and B both are parallel. And if they are parallel, ratio of coefficients must be same. 2 by 4 will be equal to 3 by alpha. This will be equal to 4 by beta. Now from here you can solve. From here when you are solving, alpha will come 6 and beta will come 8. Chumki baat, everyone understood? Bolo. Yeah, okay, very good. Yeah, okay. So this type of simple questions are asked, which we can do very easily. I'm giving you time of 10 seconds. See all these situations. We'll move to the next part. So before moving to the next part, few things I will tell you again, keep in your mind. What are the important points I will again talk about? Always remember value of magnetic force acting on the charged particle. F magnetic will be Q into V cross B. Second thing, never ignore nature of charge whenever direction of force is asked, because force is vector now. It will depend whether your charge is positive or negative. Okay. Second important point, what is work done by magnetic force? How much work magnetic force do? How much kinetic energy magnetic force changes? Zero. Why zero? Why magnet work done by magnetic force is zero? Why zero? Perpendicular. Yeah, perpendicular. Yeah. Okay, very good. Very good. Yeah, everyone remembered, everyone understood. Now we'll be moving towards next part. Understand? We'll be talking about next part. Just be focused, understand. Acha, what I told you the magnetic force will act. And always remember, whenever force acts on any charged particle, whenever force acts on any moving object, its path changes. For example, right now, if I'm saying one charge is moving in a straight line, if magnetic force will act now, its path will be not a straight line. So we are going to talk about, sir, once a charge is moving, if it comes in magnetic field, magnetic force will act. When magnetic force will act, so its path will change. So we'll talk about what are the different possible path for the charged particle in magnetic field. Sir, whether particle will continue to move in a straight line, whether particle will start moving in circle, whether particle will move in parabola, whether particle will move in hyperbola, whether particle will move. One path I am leaving, that is very, very important. Can you tell me which path I am not saying, which comes here? Which path will come here? A circle I said, Baba, straight line I said. Yeah, helical path, helix, yeah, helical path. So we'll talk about this. You write nature of path. When you will get which type of path? You write nature of path in magnetic field. Yeah, I know helical path is your favorite path. Yeah, helical nature of path. Yeah, nature of path in magnetic field. Nature of path in magnetic field. So understand how to identify whether path will be circle, whether path will be, sir, helical, whether path will be straight line. So understand how we'll be talking about. Be focused. Yeah. Actually, how to know nature of path? That is decided by the force. I said, due to force only particle moving in a straight line, but once magnetic force will act, its path will change. So due to force, so force will decide. And in force, if you look at value of force, F magnetic is Q into V cross B. Be 100% focused. Yeah, okay, no problem. If someone asks me, sir, just you tell me value of force. So if you find simply value of force now, so that will be coming as, A cross B is AB sine theta. So when you use that, value of magnetic force will come QVB sine theta. And this theta decides type of force. This theta decides nature of path. This theta will decide nature of path. Understand how this will do? Because V will be fixed. Charge will move with fixed velocity. Magnetic field will be fixed. So what can change? Change can be your theta only. So theta will decide nature of path. Now just see how many options of path we have here. Just here I will be talking about. Yeah. First option, first situation, be 100% focused. Yeah. Always remember, you tell me if magnetic field and velocity, someone is saying, sir, magnetic field and velocity both are in the same direction or in opposite direction. Velocity in this direction, magnetic field in this direction. In that situation, theta will be either 0 or 180 na. And if theta will be 0 or 180, what is the value of sine theta? What is value of sine 0 and sine 180? 0. That means, yeah, in this situation, sine will be 0. That means your magnetic force will become 0. And if magnetic force becomes 0, no force will act on charge. If no force will act, it will continue to move in straight path. So in this situation, your path will be straight line. This is the first case. Now see, yeah, undeviated. No deviation will come. It will continue to move in the same direction, same speed. Nothing will change. Yeah. So F magnetic will be 0, straight line path. Now see the next situation. Understand? Someone says, we'll talk in detail about all these paths. Someone says, sir, if angle between velocity and magnetic field. Someone says, sir, velocity is like this, magnetic field is like this. Sir, if angle between velocity and magnetic field, that is our theta, if theta is 90 degree. then always remember, yeah, in this situation, your maximum magnetic force will act, because you know QVB sine 90, sine 90 is 1. So your maximum force will act, that will be your QVB. And here path of the particle will become circle. Your particle will start moving in circular path. If magnetic field and velocity are at 90°, then your path of the charged particle will be circle. Now see the third option. See the third option. Always remember, if theta is not 0, not 180, and not 90, means if these two situations are not there. Yeah, okay. Someone said, so if theta is not 0, not 180, not 90, means your path is neither straight line, path is neither circle. Then only one option is left. Path of your charged particle will be helical. Here path of the charged particle will be helix, or you can say helical path. First you write this, come on. We'll talk about all these things separately also. Right now I'm just giving you idea. Why helical path? That also we'll talk. Nothing to worry. No fourth option. Only three possibilities are there. If magnetic field is present, if you throw a charge in magnetic field, then only three possibilities are there. Either your charge will move in a straight line, either it will move in circle, either it will move in helical. You'll never get parabola, you'll never get hyperbola, you'll never get ellipse. Only three possibilities are there. If angle between velocity and magnetic field is 0 or 180, that means same direction or in opposite direction, your path will be straight line. If angle between velocity and magnetic field is 90, then path will be circle. If angle is neither 0 nor 180 nor 90, that is none of the above two situations, then your path will be always helical. Path will be helix. Jab ki baat, everyone understood? Yeah, okay, no problem. Now be focused, be focused. I will ask you some question, then we'll move further. You tell me, if velocity and magnetic field both are in same direction or in opposite direction, what is the nature of path? What is the nature of path of the particle? Yeah, straight line, straight line, straight line. You tell me, velocity and magnetic field both are perpendicular. If velocity and magnetic field both are perpendicular, yeah, path will be circle, path will be circle, path will be circle, path will be circle. You tell me, velocity and magnetic field are neither in same direction nor in opposite direction nor perpendicular. What is the path? Helical. Helical. What is helical path? Come on, tell me. What is helix? This is helix. Yeah, moving circle. Helix means moving circle. We'll talk that. Yeah, like spring. Yeah, like spring. If you see the shape of spring, that is helical. Now we'll be moving towards our next part. You write. Circular path. I'm going to tell you circular path in detail. Circular path. Circular path. Circular path. Acha, you tell me, what is the most important thing for every particle going in circle? We have studied circular motion. What is the most important thing for circular path? Necessary centripetal force. Yeah, necessary centripetal force. Be focused where I'm trying to relate. Understand, I will be talking about. You know, whenever any object goes on circular path, it needs necessary centripetal force. Here you are saying, sir, theta 90, that means particle will go in circle. That means someone will give necessary centripetal force. Now, can you tell me who gives necessary centripetal force to the charge going in circle? Who gives? Magnetic force. Because magnetic force is making charge to go in circle now. So obviously it will supply. So this is what happens. Just see here how we'll be talking about. When angle between, whenever your magnetic field and velocity are perpendicular, theta 90, we get circular path. And whenever charge moves on circular path, it requires necessary centripetal force. And here your necessary centripetal force is given by magnetic force. Magnetic force, whose value you know, QVB, it provides necessary centripetal force. So its value becomes equal to mv square by r. Now from here what happens? From here what happen? 1v you can cancel, and you can get the radius of circle in which charge particle will move, and radius of circle becomes 1v cancel. So here left is mv by bq. This is the radius of circle in which, this is most important thing about circle is its radius now. First is centripetal force, second is the radius in which charge particle move. Now be focused, no need to write, understand few points. Always remember, in exam it's not mandatory they will give you in the terms of mv by bq. Sometimes they will talk about momentum, sometimes they will talk about kinetic energy. So always remember, you know, radius will be coming as mv by bq. Now if you want you can write mv as, what is mv? mv is momentum, so this will become p by bq. If you want you can write radius also as p by bq. Or sometimes they will not talk in the terms of momentum, they will talk in the terms of kinetic energy. So I think everyone knows kinetic energy is p square by 2m. So from there, if you write, your momentum will be written as under root of 2 ke m. This is the value of p by bq. All this depends on question, Baba. If they ask in question about mv, you will use this. If they talk about momentum, you will use this. If they talk about kinetic energy, you will use this. Or sometimes if you have studied in photoelectric effect, if a charge q is accelerated by potential difference of v, it will get kinetic energy qv. So if needed, I can write this kinetic energy also as q into v, that is accelerating potential. So this formula can be also written as under root of 2 ke. In place of ke, I can write qv into m by bq. It depends on paper setter of your NEET exam. It depends on NTA, in what terms they want to ask you. All the results are same result. Here I am talking in the terms of mv, here I am talking in the terms of momentum, here I am talking in the terms of kinetic energy, here we are talking in the terms of accelerating potential. First write this, come on. So first important thing, your centripetal force, magnetic force provides necessary centripetal force, so its value will be equal to mv square by r. So from there, when we equate qvb equal to mv square by r, we get r comes mv by bq. Or mv is momentum now, so p by bq. Or momentum in the terms of kinetic energy, you can write under root of 2 km, so the root of 2 km by bq. If they talk about accelerating potential, you can write kinetic energy as q into v. So from there we will get, okay. So come on, everyone once say, if you're not able to type, nothing to worry, but everyone will say, you speak, then only you'll be able to remember. You tell me what is the final formula for radius. What is the final formula for radius? R will be equal to, initial starting, R will be equal to mv by bq, mv by bq, or p by bq, or p by bq, or p by bq, or p by bq, then or under root of 2 k m by bq, or under root of 2 k m by bq, or under root of 2 k m by bq, or under root of 2 qv m by bq, under root of 2 qv m by bq. So this is how we are talking about. Okay. And it depends on question. And we will talk about one question from here later on. Okay, no problem. Acha, you tell me. Okay. Acha, tell me. In circular path, only does centripetal force is important, does only radius is important, or some other things are also important? Can you tell me what is that other thing? Time period of circle. You must know, sir. Okay, if magnetic field and velocity perpendicular, charge will go in circle, sir. But how much time it will take for one complete circle? So we'll talk about time period, we'll talk about frequency, we'll talk about omega. Just see here, I will be talking about. So they will ask you, if charge is going in circle now, it will complete one circle after some time. So question is asked, find the time. Time period you can find very easily. You'll be simply saying time period will be coming as, so distance by speed. So in one circle, how much distance? 2 pi r. And with how much speed? V. So from here I know, sir, this will be coming as 2 pi r. You know now, just now you have studied, r will be coming as mv by bq. upon V. So what will happen here? What will happen here? 1V cancel. So from here time period will be coming as, you can see it will be coming as 2 pi m by bq. And I think if you know time period, this is the time period that we got. And if you know time period, you also know the frequency of the charge. Frequency will be coming as 1 by t. That will be coming as bq by 2 pi m. And if you know frequency, you know omega also. 2 pi f, just put it here. So this will be giving you 2 pi cancel. That will come bq by m. And this q by m is known as a specific charge density. A specific charge density. First you write this. Yeah. Arey Baba, time, period, distance by speed. In one circle, what is the distance? 2 pi r. That is the circumference. Speed v. R, you know mv by bq. Put it there. So from there, time period will come 2 pi m by bq. Frequency, you know 1 by t. So bq by 2 pi m. If you know frequency, you know omega 2 pi f. So bq by m. Q by m is known as specific charge density. Specific charge density. Yeah, specific charge density. Charge by mass ratio. Yeah. I'm giving you time of 10 seconds. Come on, see this radius and see this time period and tell me, is something difference between, what is something, are you able to observe something different in radius and t? Just observe the formula for radius. Radius is coming, sir, mv by bq. Yeah, and observe the time period. 2 pi m by bq. Yeah, very good, very good, very good. Yeah. 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 Okay, very good. Many people are saying the answer also. Be focused, understand. Always remember, I'm just talking about conceptual point. Yeah, very good, very good. Yeah, okay. Time period is not depending on velocity, but radius is depending on velocity. If you give more velocity to the charged particle, its circle will be big, but time taken will be same. Understand what I'm trying to tell? If I have a proton, if I have two protons, magnetic field, now one proton I throw with full power, with the speed of light. You know my power is very high. Yeah. So I throw one charged particle with the speed of light, full power, and one charged particle, one proton very slowly. The charged particle which I throw with large speed now, it will make a large circle. And the charged particle which I throw with less speed, it will make a less circle. But both will return back to me after the same time. So time, because time period is independent. Look at here, velocity got cancelled. You write this point. Yeah. More speed means more radius. More speed means more radius, but not more time. You may feel a bigger circle is there, so it will take more time to come. No. More speed means more radius, but not more time. Now change the paragraph and write the statement. This statement will come in your NEET. Change the paragraph and write the statement. You write time period, frequency and omega. Time period, frequency and omega of a charged particle. Time period, frequency and omega of a charged particle moving in magnetic field is independent of speed. Time period, frequency and omega of a charged particle moving in magnetic field is independent of, if it is independent of its speed. So this is the statement which is asked, which we'll talk about. So you tell me, does radius depends on speed? Does radius depends on speed? Radius will depend, sir. You tell me if speed is more than, if you throw the charge with full power, speed more, radius more, bigger circle. but time will be same. If your particle is same, now magnetic field is same, now time will be same. So one charged particle will go in big circle, one charged particle will go in very small circle, but both will return back to the same place after same time. Everyone understood? Yeah, I'll be giving you one question. Come on, you write. We'll talk about some question from the radius. You write. Yeah, I'll give you first one previous year NEET question. You write. A proton and an electron. A proton and an electron having same kinetic energy. A proton and an electron having same kinetic energy are projected in same magnetic field. A proton and an electron having same kinetic energy are projected in the same magnetic field. Are projected in the same magnetic field. Then a proton and an electron having same kinetic energy are projected in same magnetic field. Then you have to tell me whose radius will be more or less or equal. Radius of proton will be same as radius of electron. Second, radius of proton will be greater than radius of electron. Radius of proton will be less than radius of electron. Fourth, can't say. Akhilesh sir did not told us. So how we can say? Yeah, Prashanti, very good. Harini, very good. Yeah, Charisma, correct. Yeah. Tell me the option, Baba. Janvi, correct. Snehita, you are doing mistake, Ladki. Don't you know? Patnaik, very good. Yeah. Abul, very good. Galaxy, very good. Boys have kept their name in the terms of Galaxy. Change the name of mobile phone. Put your name. Arshia, correct. Harika, correct. And don't do mistake, Baba. Hemant is saying correct. Very good. Sony, very good. More correct answer are coming from girls. Boys are giving very less correct answer. Okay, Sai. Arey Baba. You must know whose mass is more, proton or alpha. Whose mass is proton or electron? Proton, na. Answer will come, second option will come. This is the correct answer. Don't do mistake. I'll be simply saying, okay, just be focused, understand, I will be talking about, yeah, okay, no problem, just here. First thing, okay, leave your copy, be focused, yeah. You have 4 formula for radius, sir. Which formula I will use will be decided not by you, will be decided by your paper setter. He's talking in the terms of kinetic energy. So use formula for radius. R will be coming as under root of 2 Ke m by bq. This result you are going to use, yeah, under root of 2 Ke m by bq, because they are talking in the terms of kinetic energy. That's why we'll use this result. I'll be simply saying, now you have to see in the question, sir, 2 will be same. When I will compare, sir, 2 will be same. Kinetic energy given same. Magnetic field given same. Charge of proton and electron is also same now. So charge is also same. That means radius will come directly proportional to root of mass. That means mass more, radius more. Directly proportional. Who has more mass? You'll be simply saying, sir, mass of proton is greater than mass of electron. That means from here I can say radius of proton will be greater than radius of electron. That's why we'll be getting second option. Yeah. So everyone got, everyone understood? Come on, do one more question. Come on, Targa. Come on. You write. You write. A proton alpha particle and deuteron. A proton, alpha particle and deuteron, all having same kinetic energy. A proton, alpha particle and deuteron, all having same kinetic energy. All having same kinetic energy, enters in same magnetic field. A proton, alpha particle and deuteron, all having same kinetic energy, enters in same magnetic field. Find, first you write, ratio of their radius. Find first ratio of their radius. Second, ratio of their time period. This is also such question has been asked previously in your NEET. This radius part is very, very important. Always probability is there. Question to be asked in your NEET. Find ratio of their radius and ratio of their time period. Yeah, Harini, very good. Don't do mistake. Yeah, Sai correct. Shoni correct. Prasanti correct. Aruna correct. Very good. Yeah. Prashanti's second answer also correct. Very good. Snehita, don't do calculation mistake. Yeah. Chandu, don't do calculation mistake. Okay, no problem. All having same kinetic energy enters in same magnetic field. Find ratio of their radius. Find ratio of their time period. I think ratio of radius is coming 1:1 root 2. 1:1 root 2. That is the ratio of ratio of radius is coming. 1:1 root 2. Yeah. And ratio of time period is coming. 1:2. Yeah. Ratio of time period is coming 1:2. Yeah. This is what we have. This is what we have. Yeah. Okay. Yeah. Yeah. I think everyone is getting the answer. Everyone is getting the answer. Still, if you have problems, see for the last time how to deal, how we'll be talking. It's very easy, Baba. First thing, always write, you'll be simply saying, sir, when I read the question. Acha, everyone knows about proton, alpha and deuteron. I told you previously also, again for the last time I'm telling, if mass of proton is m, charge is q. Alpha mass, what is mass of alpha? What is mass of alpha? Mass of alpha? 4m. Mass of the alpha will be 4m. Those who don't know, write this thing. Charge 2q. And deuteron means isotope of hydrogen. You get a protium, deuterium, tritium. So from deuterium, if you remove one electron, that is your deuteron. So that will be coming as, how much it will come. So its mass is 2m and charge is q. You must know this thing. Yeah. Okay. Very good. Okay. No problem. Yeah. If you know this thing, you can find. You'll be simply saying, sir, they're talking about radius and the question they are saying us about kinetic energy. So I'll write the formula for radius in the terms of kinetic energy. That is under root of 2ke m by bq. This is what I will get, sir. Now from here, I'll be simply saying, sir, what is given in the question? I will see, sir, kinetic energy same. So no need to take 2 same, no need to take b same. That means our radius will finally come proportional to under root of m by q. Now use it now, Baba. Radius of proton is to radius of alpha is to radius of deuteron. Those who are not able to do, for them only I am doing. So this will be coming as, yeah, root m by q. This will come. How much it will come? Root 4m by 2q. That is for alpha particle. Under root of. This will come 2m by q. Now from here, if you solve m by q, cancel. This will come finally 1:2. This is root 2, root 4. Root 4 is 2. 2 will get cancelled. So 1:1 root 2. This is the answer. Yeah. Okay. I think everyone got also. Nothing to worry. Yeah. Okay. Now someone asked me about time period. Just I am doing. Okay. Time period. Someone asked me. So time period I know, sir. For time period, no other formula. Only one formula. 2 pi m by bq. So no need to take 2 pi, no need to take b. So time period will come directly proportional to m by q. Now I can use, sir, T of proton. T of proton is to T of alpha is to T of deuteron. That will be coming as m by q for proton. For alpha, come on, 4m by 2q. For deuteron, how much it will come? For deuteron, how much it will come? How much mass? 2m by q. So I think 2:2. Acha, 1:2. Yeah. Oh. Very intelligent students. Yeah. Everyone got these answers? Come on. Yeah. Okay. No problem. So this is how we have talked about. I'm giving you time of 10 seconds. Come on. See once again. See the radius. See the time period. We'll move to the next part. Come on. This is very, very important type of numerical. They may ask you in the terms of momentum. If they ask you in the terms of momentum, you will use P by BQ. So it depends on the question, what is given. As per that question, you can use. Now we'll be moving towards next part. You write. We'll be talking about next situation. You write. Acha, till now I talk about circular path now, but I told you path can be helical also. So I will talk about helical path. Why path will be helix? You write helical path. Helical path. Helical path. And always remember, helical path means moving circle. Actually, helix means moving circle. If your circle starts moving in forward direction, it is known as helix. For example, just see here. This is circle. This is circular path. This is circle. This is circle. If center of the circle is fixed now, this is circle. But if center of the circle starts moving in forward direction, this is helix. Arey Baba, look at my finger. This is circle. This is circle. But if I'm saying, sir, I'm moving in circle, but if my hand started moving in forward direction, this is helix. This is helix. This is helix. Moving circle in forward direction is known as helix. Okay, no problem. So understand why path will be helical, why when theta is not 0, not 180, not 90, why path is helical. You'll get idea from here. Understand? Yeah. What I said you, for helical path, sir, theta should not be 0. It should not be 180. It should not be 90. Let's take one general theta. Sir. So let's assume, sir, magnetic field is in this direction. Let's assume magnetic field is in this direction. And velocity of the particle is in this direction. And you see angle between them is theta, which is not 90, which is not 0, which is not 180. Understand? Be focused. Understand why path becomes helix, sir. What is the actual meaning of helical path? You'll get idea from here. So see here, I'll be simply saying, okay, sir, what will be nature of path? I already know that path here is going to be helical. Someone says, why? Why helical path? Actually, what happens now, if you look closely, you have to observe this thing. If you look closely, you'll say, sir, here velocity V, magnetic field B. Sir, here velocity will have two components. If you see closely, one component of velocity is perpendicular to magnetic field, that is your V sine theta. And one component of your velocity is in the direction of magnetic field, that is parallel component, that is your V cos theta. Be focused, understand, you'll get idea from here why path is helical. So actually what happened when you throw the charge at an angle theta with magnetic field, your velocity has two components, one perpendicular to magnetic field, one parallel to magnetic field. And you know, whenever any velocity is perpendicular to magnetic field, charge will move in circle. So actually due to V perpendicular, due to V sine theta now, charge starts moving in circle. You know, whenever magnetic field will be perpendicular to velocity, circle will start. So due to this V perpendicular, circle motion starts. Circular motion, charge started moving in circle. But V cos theta is also there now. So due to V cos theta, charge move forward. And due to V sin theta, it starts moving in circle. What will happen? Due to V sin theta, circular motion start. But V cos theta is also there now to move in forward direction. So due to that V cos theta, that circle starts moving in forward direction. And that forward moving circle is your helix. So actually what happens, due to V sin theta, look at, due to perpendicular component of velocity, you know, velocity and magnetic field perpendicular, what happens? Circle started moving in circle. But this V cos theta is there now. This V cos theta will make it to move forward. So what happens? You get circle, and that circle starts moving in forward direction. And when that circle starts moving in forward direction, the path that we get is known as helix. This is the path. This is known as helical path. First you write this, come on. That's why path is helix. One component that is perpendicular to magnetic field makes charge to go in circle. And due to other component parallel to magnetic field, it moves in forward. So circle moving in forward is your helix. Are you getting idea why we get helical path? Why helical path is like this? Everyone is busy in writing. Oh, yeah, okay, yeah, okay. Okay, yeah. Which component of velocity is responsible for circle? Two component of velocities are there now. Which component of velocity? Perpendicular component. Don't say vertical, Baba. Perpendicular. Sine theta component, perpendicular component. So always remember, we also talk about radius of helix. Questions are also asked, what will be the radius of helical path? Radius of the spring, radius of helix. So always remember this radius of helix will be coming as radius will come due to circle now. For circle, V sine theta is responsible. So radius of helix will come m into V sine theta. You will not use whole V because whole V is not responsible for circle. Only V sine theta is responsible. So m into V sine theta by BQ. That you can also say m into V perpendicular by BQ. This is the radius of helix. And time period will be again same. Time period has nothing to do with velocity. Time period will be again same. That is 2 pi m by BQ. Yeah, okay, no problem. And always remember, okay, now be focused, something new I'm going to tell you. So be focused, understand. Always remember, for every helix, we talk about one more quantity. That quantity is known as pitch of helix. Understand how we'll be talking about? Yeah. Pitch of helix means, just here how we'll be talking about. Yeah. Actually, what is happening? Your charge is going in circle now. At the same time, it is moving forward also. So in one complete time period, how much distance it move in forward direction? That distance is known as pitch of helix. You write pitch of helix. Yeah. You write pitch of helix. Then I will tell you how to calculate. Right, pitch of helix. You write it is the distance moved in forward direction. It is the distance moved in forward direction by the charge. It is distance moved in forward direction by the charge in one complete circle, in one complete time period, in one complete time period. It's the distance moved by charged particle in forward direction during one complete time period. During one complete time period. Okay, no problem. Acha, you tell me. So this is your pitch. For example, one circle here na, other circle here na, other circle here na, other circle is here na. So these distances are known as pitch. During one complete time period, distance moved by the charge in forward direction. This is pitch. And can you tell me what is the value of pitch? Pitch is simply distance na. Distance will be simply velocity into time na. You tell me which velocity is making to move in forward. Which velocity is making to move? Yeah, v cos theta. So this distance will simply come v cos theta into t. Or you can simply say, sir, v parallel into t. And t you know. If you needed, you can write v cos theta into t. T you know, 2 pi m by bq. So this is the pitch of helix. This is the pitch of helix. First you write this. Okay, no problem. So first thing you tell me, come on, tell me. Yeah, you tell me in helical path, which velocity makes the charge to go in circle? Which component of velocity makes the charge to go in circle? Yeah, component of velocity perpendicular to magnetic field. Due to that perpendicular component, charge moves in circle. Due to which component it moves in forward direction? Due to which component moves in forward direction? Parallel component. Parallel component. You tell me what is meaning of pitch of helix? What is meaning of pitch of helix? Yeah, distance in forward direction during one complete time period. How much distance charge move in forward direction is known as pitch of helix. I will give you one question. Come on, do very fastly. Come on. Yeah, you're right. For the given charge particle, find radius and pitch of helix. Find radius and pitch of helix. For the given charge particle, find radius and pitch of helix. First, see which component of velocity will decide radius. That is a perpendicular component. Magnetic field is along J. So which component will decide radius perpendicular to magnetic field? Patnaik, very good. So only don't do mistake. Yeah. See which component of velocity is perpendicular to magnetic field. Use that velocity for R. I will say, yeah, 1.5. Radius will come 3/2. I'll be simply saying, sir, what you want? I know, sir, on helical path. Sir, helical path, I know radius. Radius will come, sir, MV perpendicular by BQ. What is M? M is 1. What is V perpendicular? Which component? This is along J cap now. So which component will perpendicular to J cap? I cap. So you have to select only that velocity which is perpendicular to it. So which component is perpendicular? 3. So M into V perpendicular 3. By B, what is B? 2, Q1. So this will give you 3/2. 3/2 means 1.5 meter. Hey Bhagwan, chala sulabam prasna. Chala sulabam. Sir, you want pitch na? Pitch means mad. I know, pitchy means maddy. Yeah, so pitch means mad. So calculate, become mad and calculate. What is pitch? Pitch is, sir. Pitch is, sir. Sir, pitch. Pitch is V perpendicular into T. V parallel into T. Yeah, V parallel. What is V parallel? Which component is parallel to magnetic field? C, Baba. 4. So what is parallel component? That is 4. Into T, you know, 2 pi m. 2 pi m by BQ. What is B? B is 2 into Q. Q is 1. So from here we will get 4 pi. Pi value you can put around 12 meter. Chamki baat bolo. Come on. Twarga, everyone understood? Everyone understood? Come on. Yeah. Okay. Very good. Yeah. Okay. No problem. I'm giving you time of 15 seconds. Come on, revise all these things. We'll move to the next part. See all these situations. Once you'll revise, you can say done, sir. Once revision will be completed, you can say done, sir. I know, now everyone will start typing done, sir. Oh. Yeah, okay, no problem. Now be focused, understand how we'll be talking about. Yeah. Now, okay. Now we are going to talk about one device. One device is very famous here, from where conceptual questions are asked. Numericals will be also asked, but numerical is directly based on formula. But some conceptual questions are asked. Again, important part, you write the device cyclotron. Yeah, cyclotron means cyclone of electron. Cyclone of electron means highly energetic electron. Highly energetic electron means highly energetic charged particle. So that is the use of cyclotron. Cyclotron comes from tron means charged particle. Cyclone means highly energetic. So you write. It is a device. It is a device used to obtain. It is a device used to obtain highly energetic. It is a device used to obtain highly energetic charged particle. It is a device used to obtain highly energetic charged particle. Hence it is also known as charged particle. Hence it is also known as charged particle accelerator. So question has been asked previously, NEET also, which of the following is charged particle accelerator? They gave transformer, they gave DC generator, AC generator, cyclotron. So cyclotron is charged particle accelerator. Okay. Yeah, charged particle accelerator. So first thing, sir, what is purpose of cyclotron? Always remember, cyclotron is a device which is used to obtain highly energetic charged particle. Actually, some experiments we perform in physics where we need electron which has a speed of very high speed. So there we need this cyclotron. So first thing, you tell me what is use of cyclotron, what is the purpose of cyclotron, why cyclotron is used, what is the purpose of cyclotron? To obtain highly energetic charged particle. To obtain highly energetic charged particle. That's why its other name is, come on, tell me what is the other name? What is the other name of cyclotron? Charged particle accelerator. Charged particle accelerator. Okay, so this is how we talk about this cyclotron. Okay, no problem. Now understand how this cyclotron works. How this cyclotron works. Come on, everyone will say, oh. Yeah, you tell me what is use of cyclotron. Why we design cyclotron? Why we design cyclotron? Yeah, to obtain highly energetic charged particle. First thing. What is the other name of cyclotron? What is the other name of cyclotron? What is the other name of cyclotron? Charged particle accelerator. Charged particle accelerator. Yeah. Okay, no problem. Now understand how this cyclotron works. Be focused, understand. Be focused, understand. I will be talking about. Yeah. If you want to solve the question in your NEET, you must know about the construction, basic construction. So understand how we'll be talking about. Just see. Actually, what happened, you may have studied. So just see, we'll go in little detail. Actually, what happened now, in cyclotron, we have two semicircular shape structures whose shape appears like D, whose shape appears like alphabet D. So these are known as Ds. These are known as Ds of cyclotron. These are known as Ds of cyclotron. Okay, no problem. Keep on understanding. Okay, no problem. And what happens? What happens in cyclotron? Okay, in cyclotron, what happens? On the Ds of cyclotron, we have magnetic field. On the Ds, you will have magnetic field. Here we will have magnetic field. On the Ds, we have magnetic field. Okay, no problem. And between the Ds, are you seeing that some space is there now? Between these two Ds, some space is there now. Nothing is present here now. So between the Ds, we have electric field, which is generated by, between the Ds, we have electric field, which is generated by one oscillator. One oscillator is there, that is source of EMF, source of potential. Actually, what happens, this oscillator maintains some voltage. Actually, oscillator is like source of EMF, source of potential. Source of potential means it will maintain one D at high potential, other D at low potential. So what will happen? So you know electric field will be always there from high potential to low potential. First should draw this. This is a basic diagram. So always remember, on Ds we have magnetic field, On the D's we have magnetic field, between the D's we have electric field. So you write this point. You write this point. Yeah. Sir, you took vaccine. They are not giving vaccine to young people. Yeah. In campus, we have vaccine, means they were giving vaccine to everyone. Yeah. They said for young people, we are not giving right now. I said, okay, no problem. Yeah. Yeah. I went for vaccine. I went, yeah, give to me, but they denied. They said below 25, not required right now. Yeah. Yeah. Oh. Okay. Now be focused. Be focused. Understand. Understand how we'll be talking about. Just see. Yeah. Okay. So you write this point. Oh. You write this point. Yeah. You write. On the D's, we have magnetic field. Oh. On the D's, we have magnetic field. And between the D's, on the D's, we have magnetic field. And between the D's, we have electric field generated by potential difference. And between the D's, we have electric field generated by potential difference. Generated by potential difference. Now understand how we'll be talking about bring understanding of working of cyclotron. Bring understanding, then only you'll be able to solve good questions tomorrow. So be 100% focused. Just see here how this cyclotron works. Just see here. Okay, sir, we understood. Okay, in cyclotron, two D-shaped structure will be there. Those will be known as Ds. Sir, on the Ds, magnetic field will be there. Between the D's, electric field will be there. That electric field will be generated by some source. That source is known as oscillator. Oscillator is there. Why this is oscillator, we'll talk everything later on. Be focused. Understand what actually happens. Just here. If you want to accelerate any charge particle, for example, assume here I'm having one proton. I'm having one charge. I'm having charge Q. I'm having one charge Q here. Okay, no problem. If I want to accelerate any charge, now I will put here. For example, if I put charge Q here, once you put charge Q now, between the D's, electric field is there now. You know electric field will be from high potential to low potential. So due to electric field, your charge will experience electrostatic force. F will be equal to QE. Due to that force, your charge will have acceleration from here to here. It will come from this D to this D by accelerating through electric field. But once it will come in this D now, on the D, what is present? Magnetic field is present. And you know, whenever any charge goes in perpendicular magnetic field, it moves in circle. So once this charge will come from this D to another D, this magnetic field will again rotate the charge to bring back between the D's. And once your charge will again come at the D, this is oscillator. Why we need oscillator? Why we don't use a battery, sir? Oscillator means its polarity will oscillate. Right now plus minus now, so after some time it will become minus plus. Understand what I'm trying to tell? Why polarity must oscillate? Because once your charge will come from here to here now, your electric field direction must change. If your electric field direction will not change, your charge was accelerated from here to here now. So now when it will come from here to here, it will get retarded. So that's why once your charge goes from one D to another D, sir, here magnetic field is there. Due to magnetic field, it moves in circle. And once it comes here, oscillator reverses the polarity. It makes this D positive and this D negative. Again, you can see electric field will be from plus charge to from high potential to low potential. Again, due to this electric field, your charge will accelerate. Again, due to acceleration, once it will come on this D, again magnetic field is there. Now, again this magnetic field will make it to move in circle. Again, it will come. Again, when it will come here, polarity must be reversed. Then only it will now again accelerate. That is the use of oscillator. That's why I'm not using battery. Your polarity must keep on changing. So once your charge will again come, again it will reverse the polarity. It will become plus. it will become minus. Again, electric field will be in this direction. Again, charge will speed up. Again, speed of charge will increase. Again, it will come. Again, it will come. Again, it will go. So what will happen inside your D's? It will keep on making circle, 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 circle. And finally, after making millions of circle, finally your charge will come out. And when your charge will come out now, since it make million circle now, you see in every circle its speed is increasing twice, once while coming, once while going. So what happen if I say it makes 10 lakh circles, how many times its speed increased? Come on, tell me. If it make 10 lakh circle, how much times its speed increased? 20 lakh times. So slowly speed increases, and finally when charge particle comes now, it has very high kinetic energy, which you can calculate also. You'll be thinking, say, sir, how to calculate energy, kinetic energy? You can find, because these D's are designed by you now. Who has designed these D's? You have designed. So you always know the radius of the D's, and if radius of the D's are known now, look at the radius of the final circle. Come on, tell me, what is the radius of final circle? Radius of final circle will be same as radius of your D's. Someone says, okay, sir, I understood final kinetic energy will very high, but tell me the value. You can calculate value also, because final circle radius. Look at the radius of final circle. I will use the different color. Okay, no problem. Yeah. If you look at the radius of final circle, look at, this is your final circle. Radius of final circle is same as radius of your D's. And if you know the radius and this radius you know, and if you know this radius, you know this radius will be under root of 2ke m by bq. So you can find kinetic energy. You know now radius is under root of 2k. So this radius you know, because these are designed by you. Magnetic field you know the charge, you can find kinetic energy. If you square both sides, this will become r square will become 2ke m by b square q square. So from here you can get kinetic energy. So kinetic energy will be coming as, b square r square q square upon 2m. This is the kinetic energy of the charged particle that will come. This is what happens in your cyclotron. So actually electric field is increasing speed and magnetic field is bringing it back. Are you getting the feeling? What is happening? Electric field pushed the charge, but magnetic field again bring it back. So again it came, electric field speed up, electric field increases the speed, but once it will come in magnetic field will again bring it back. Again came, again speed increases, again came, again speed increases, again came, again speed. So who is bringing it back between the D's? You tell me, who is bringing back between the D's every time? Who is responsible for bringing the charge back? Yeah, magnetic field. Very good. Magnetic field is responsible for bringing the charge back to the D's, because these are the place where electric field is present, where charge will accelerate. And why I'm not using battery? Why we need oscillator? Why I'm not using battery? Why I'm using battery? Yeah, because polarity must change, sir. The instant it will come now, it must change. It must change from positive to negative, again from negative to positive. Then only charge will keep on accelerating. So this is how we talk about these things. Okay. Everyone has written. Now understand few points which are asked from here. So numericals will be asked from here, and here always remember, from here we get energy in the terms of joule, because this is SI system. SI system, everything will be used in SI system. But in exam when they will ask you kinetic energy in the terms of electron volt. And I think everyone knows 1 electron volt will be equal to 1.6 into 10 to the power minus 19 joule. So you can use this result for conversion. Okay, no problem. Yeah. Now understand, few theoretical questions are asked which I am going to talk about. Understand. Just here I will be talking about. As you tell me, where speed is increasing, on the D's or between the D's? Where speed increases? Between the D's. And where direction of velocity changes? On the D's. Yeah, on the D's. You write this point, come on. Yeah, you write. You write. Charge speed increases between the D's due to electric field. Charge speed increases between the D's due to electric field, and direction of velocity changes on the D's due to magnetic field, and direction of velocity changes on the D's due to magnetic field. Due to magnetic field. Actually, tell me where your charged particle has acceleration, where your charged particle is suffering acceleration, on the D's or between the D's? Both. Yeah, okay, very. Always remember, acceleration means change in velocity. Between the D's, change is happening due to magnitude, and on the D's, change is happening due to direction. Students think that acceleration in cyclotron is only present between the D's, speed only increases, but on the D's, direction also changes now. So always remember, you write this point. Throughout motion of charge in cyclotron is accelerated. Throughout motion of electron, throughout motion of charge in cyclotron is accelerated. So tell me, if anyone asks you where the charge particle has acceleration in cyclotron, where the charge particle has acceleration in cyclotron, come on, tell me. Entire, yeah, completely everywhere. You tell me between the D's why it has acceleration, between the D's what is the reason for acceleration, between the D's what is the reason for acceleration? Yeah, speed, magnitude changes, yeah. On the D's what is reason? Yeah, direction changes. And you know, acceleration means it can come due to change in velocity, change in magnitude, or in the change in direction. Now be focused for last thing, understand? Yeah, always remember, this oscillator has frequency. Obviously, sir, oscillator is there, so oscillation means frequency will be there. And this frequency means frequency of oscillator is same as your frequency of charge, because whenever charge comes here, it also has to change the polarity. So frequency of oscillator, frequency of oscillator is same as frequency of your charge, and this is also known as frequency of cyclotron. Frequency of cyclotron, that will be coming as just now you studied 2 pi m by bq was time period, so it will be coming as bq by 2 pi m. This is the frequency of, this is the frequency of your cyclotron. Now you tell me, does this frequency, speed is increasing now, radius is increasing now, does this frequency is also increasing? Does this frequency? No, it will, time period will not depend on speed, time period will not depend on radius. The same manner, frequency will also not depend, and this is the reason, this is the basic working principle of cyclotron. You write, come on, yeah, you write. Working of cyclotron is based on the fact that working of cyclotron is based on the fact that frequency of charge working of cyclotron is based on the fact that frequency of charge do not depend on its speed. Frequency of charge do not depend on its speed. So speed keep on changing. So speed keep on increasing. Frequency working of cyclotron is based on the fact that frequency of charged particle do not depend on its speed. So speed keep on increasing, but frequency remains same. So speed keep on changing, increasing, but frequency remains same. So this is how we have talked about, and this is how we have completed cyclotron also. So that is how we have completed today's class. More situations from here we'll be talking in our next class. Happy Ugadi to all of you. Take care, study well. Bye bye, bye bye, bye bye. STC, okay, tata, bye bye, bye bye, bye bye, bye bye.